3F, improving measurements. Recall accuracy and precision. 4 students weighed an object and reported back with these masses. N, 15 grams, Bob, 16.025 grams, Carl, 18.0334556 grams, and Doug, 25.00000000012 grams. If the actual or accepted mass is 16.0202 grams, who was the most accurate? Bob was the most accurate as his measurement was the closest to the actual or accepted mass. Who was most precise? This may surprise you, but Doug was the most precise because even though he was not accurate, he measured to the most decimal places, making him the most precise. Improving measurements. What are some things that you can do to make your measurements more accurate and more precise? What can we do to make better measurements? One thing we can do is measure larger if possible. Measuring larger properties results in smaller relative uncertainties. Let's measure the radius of the circle. To me, it seems to be 57.5 millimeters plus or minus 0.5 millimeters. If this is the case, then the relative uncertainty, which is absolute uncertainty divided by measurement times 100%, works out to be 0.5 millimeters divided by 57.5 millimeters times 100%. The relative uncertainty for the radius of the circle is 0.8695%. So try measuring larger if possible. Let's measure the diameter instead of the radius. If we measure the circle to be 114.5 millimeters plus or minus 0.5 millimeters, then the relative uncertainty works out to be 0.5 millimeters divided by 114.5 millimeters times 100%. The relative uncertainty for the diameter is 0.4367%, roughly half the uncertainty of the radius. Another way to improve measurement is to measure many versus few. Averaging will reduce uncertainty by the same factor. For example, try measuring the thickness of a piece of paper. The measurement using a millimeter ruler would be near impossible to be accurate and precise. The uncertainty alone using the standard practice of 1/2 the smallest gradation would be plus or minus 0.5 millimeters. The thickness of one sheet of paper is roughly 0.1 millimeters. The relative uncertainty would then be 0.5 millimeters divided by 0.1 millimeters times 100%, or 500%. If you measure a stack of 250 pages, the relative uncertainty of the group of pages is the same as the relative uncertainty for a single page when you divide to determine the thickness of the single page. If we estimate the stack of paper has a thickness of 23.5 millimeters with an uncertainty of 0.5 millimeters, the thickness of a single page is 23.5 millimeters divided by 250 pages, which makes a single page thickness roughly 0.094 millimeters thick. However, the relative uncertainty for a single page will be the same as for the stack of paper, which is 0.5 millimeters divided by 23.5 millimeters times 100%, 2.13%, which is well below the 5% limit for a good measurement. Use a better scale or device. For example, a millimeter ruler would provide a measurement with an uncertainty of 0.5 millimeters, while a centimeter ruler will give measurements with an uncertainty of 0.5 centimeters or 5 millimeters, 10 times the uncertainty of a millimeter ruler. Finally, if you're measuring something that seems to vary due to uncontrollable variables like background noise or wind, use averages to minimize the overall effect of the measurement. Ideally, use 4 to 10 readings,